Let's talk about Apache Storm, which is another way of processing continuous streams of data, this one being more real-time in nature. So like Spark streaming, it can process continuous streams of data that are getting sent into a cluster as they come in, pretty much forever. And like Spark, it can also run on top of Yarn if you'd like it to, but Storm is kind of its own thing. It was developed on its own. The main difference between Storm and Spark streaming is that Storm works on individual events and not micro batches. So with Spark streaming, remember, you're dealing with these small little RDDs that represent the data that was received within a given batch interval. But with Storm, it's working on the event by event level. So if you do need sub-second latency for your processing, and it's kind of hard to think of applications where that's really a requirement, but if that does describe what you need, Storm is for you. It can operate much more quickly on data exactly as it's received, and it does not have to wait for batch intervals to kick off its processing. Storm has its own little world of terminology, so the very basic concepts of Storm are this. Basically, you have a stream, and a stream, you're already familiar with that concept. It's just data flowing through your system in real time in a continuous manner. Streams consist of tuples of data, and tuples are just, lists of information that get sent through your system. So for example, a 3 tuple would contain, for example, the numbers 5, 7, and 33, or 3 different strings or something. They're just collections or lists of data that get grouped together. So that's what flows through your stream. Now, your stream originates from what it calls a spout in Storm. So spouts are your sources, and that could be coming from Kafka or Twitter or some database connection or some TCP port or whatever you can code against. Basically, you can write your own spouts that get data from wherever you want. But a spout is where the data is input into Storm for further processing. And the actual processing of your data that's coming from your spouts is done by what's called bolts. So you set up these bolt classes in Storm that actually transform or aggregate data as it comes through, and it can also write out your output as well to databases or HDFS or logs or whatever you want to put your output into over time. But just remember, bolts are processing streams of data continuously, so there's no final result that you're going to be writing into databases. Instead, it's going to be ongoing, changing results over time that just keep on going forever and ever. And spouts and bolts are connected together in what's called a topology, which is kind of like a DAG, but you can assemble these components together however you want. I mean, often they'll be very simple. You'll just have a spout going to a bolt and maybe to another bolt, and that's the end of the story. But you can also chain things together in more elaborate manners. So maybe I have 2 different spouts of information, and some bolts are handling both spouts at the same time, and some are just processing one or the other, and maybe there are bolts that are going into other bolts for further processing. So you can put things together in complex ways that can be kind of interesting. So if you have more of a complex chain that you want to do, a topology is how you set that up. Now this is analogous to a Spark directed acyclic graph, which it constructs for you automatically in an optimal manner, whereas in Storm you have to think about it. How are these things actually put together in an optimal way? Storm itself is architected in this manner. So it has a Nimbus node, which is a server. It's kind of like your job tracker, so it's keeping track of where everything is and where it's all running. Technically, that is a single point of failure, but in practice, I'm told that it's not that big of a deal. If it goes down, you can start it back up quickly without losing anything. And there is a high availability version of Storm these days where you can have a backup Nimbus server that can be switched to automatically. Everything goes through Zookeeper, which itself is highly available. And the supervisor nodes are where all the work actually happens with Storm. So these are what are actually running your workers and the actual worker processes within them. Developing Storm applications usually is done with Java. One of the selling points of Storm is that they claim you can run it with any language you want, because you can set up a bolt that actually gets directed through any script in any language you want through streaming. Although in practice, usually you see Storm applications written in Java. I've never seen an example of a Storm application written entirely in a different language. And I've only seen actually one example of anything other than Java being used at all. So from a practical standpoint, you'll be very hard-pressed to find examples or tutorials for getting started with Storm in anything other than Java. Now, there are 2 different APIs you can choose to develop against with Storm. One is called Storm Core, which is basically a lower-level API for Storm, although it's still pretty simple to use. I don't want you to think that you're really getting mired in the details here too much. It's still abstracting away all the nastiness of distributing your work and making sure things are running in the right place. Storm Core offers at least once semantics, so there is a possibility of receiving duplicate data with Storm Core. However, more and more people are choosing to code instead against Trident, which is a higher level API for Storm that sits on top of Storm Core. So Trident will forward your code down into Storm Core, where it actually does stuff in Storm. So it's kind of this extra layer, which I'm not too keen on, but it does offer a easier API for writing your Storm applications and putting your topologies together. And Trident also offers exactly once semantics, which you can also get with Spark Streaming. And remember, Storm will just run these topologies forever once you submit them to Storm, and you have to explicitly stop them when you're done. So once you kick off Storm and your little script to actually submit the job goes away and you're not done, it's just going to keep on running forever until you do something to actually explicitly stop that job. So easy to forget that when you're actually messing around with it. So you might think to yourself, well, how do I choose? Storm and Spark Streaming, they kind of solve the same problem. Well, there are some differences to think about. First of all, if you do want to have the rest of Spark at your disposal, there's a lot to be said for that. And with Spark Streaming in particular, you can do things like integrate with MLlib for machine learning, or integrate with GraphX for doing graph processing. So there's a lot of other capabilities in Spark that you can use to your advantage when you're using Spark Streaming. And to me, that's a huge plus. I also kind of like Spark as a developer because it lets me develop in Scala or Python if I want to, instead of messing with Java, but that's a personal preference. However, like I said, if you need truly real-time processing sub-second on an event-by-event basis, Storm would be your clear choice, because Spark Streaming deals with micro batches, which can be, as little as 1 second, but they are still micro batches and not actual events. So if you need truly real-time processing, Storm is going to be the winner, but I'd be pretty hard-pressed to think of a real-world example where that would be an absolute requirement. But one side effect of having that truly real-time processing is that in core Storm, if you're doing windowed operations, remember in Spark Streaming we talked about doing windows of data over time where we aggregate data over, say, the past 5 minutes or past hour or whatever. In core Storm, you can do tumbling windows in addition to sliding windows. And that means that as data comes in, you can say, I want all the events that came in the past 5 seconds, exactly 5 seconds. And as new data comes in, you'll get another window of data after 5 seconds that contains the next sequence of events for those 5 seconds, and so on and so forth. So with tumbling windows, you can make sure that there's no overlap in events that get processed, whereas with sliding windows, they can overlap by design. So that's kind of an interesting feature that Core Storm offers that you don't see in Spark Streaming necessarily. I will say that the combination of Kafka and Storm seems to be a pretty popular one. It's kind of hard to get statistics on this, of course, but just in reviewing the literature and the tutorials that are out there, it seems a lot of people are using Kafka and Storm together. However, it does seem like Spark Streaming is gaining a lot of momentum because Spark itself is gaining a lot of momentum. And again, these are just my personal observations looking at what's out there on the internet and what people are talking about. There are no statistics that I've seen to actually back that up, but that's kind of my feeling. Spark Streaming seems pretty hot, and Spark itself seems pretty hot too. Storm, also a great technology and very popular. It's a little bit more established than Spark Streaming at this point, and Spark Streaming is still changing rapidly, I should point out as well, whereas Storm's a little bit more solidified at this point. Although there is a 2.0 release that's in the works right now, which will be a bit different. So with that, let's play around with Storm. Now, I don't want to get mired in all the details of actually building and deploying Java applications, so I'm just going to use one of the samples that comes with Storm itself, and we'll mess around with it. Very simple topology we're going to set up here. We're going to have a spout that just generates random sentences. So it has a library of sentences that it just spits out at random over and over again forever. We will hook that up to a bolt. That is just a bit of code that splits those sentences into individual words, and that bolt is connected to another bolt that keeps count of how many times each word appears over time. So fundamentally, this is just a split operation that splits sentences into words, and this bolt is just a big old hash map that keeps track of how many times each word appears over time. And those updated counts will be emitted to the logs as the final output of this topology. So let's go make that happen in our next lecture.